Okay. So Sasha, I'd like you to read the question. So Sasha, you're gonna do this question with me. And Aliyah, you're gonna help me with the second question. Yeah, that is how we're gonna go. So Sasha, give this question a read.
Connie leaves home on her bicycle to visit her grandparents. The graph shows her journey. A. How long does she stay with her grandparents? B. Which journey is the faster, the outward journey or the homeward one? C. What was her average speed? On the outward journey, on the homeward journey, for the total time what she was cycling.
All right, Sasha, let me see if you remember. So what kind of graph is this? Is it a velocity time graph or a distance time graph?
Distance time?
Right, it literally says distance. Can't get that one wrong. It's a distance time graph.
Yeah.
So what this means is that they're saying that she's leaving home to visit her grandparents. Now, if you leave home to visit your grandparents, will you stay by your grandparents for some time?
Yeah.
Yeah, and then you go do what? After you finish see your grandparents, what you go do?
Like go home.
You go home. So can you tell me which part of the journey represents you going to meet your grandparents?
Want to have to?
One to half two? No. Um, one is where you're going to meet your grandparents.
Oh,
See,
like
see, arrive at your
so it
grandparents.
could
So
be like
the answer is one. One represents your journey to meet your grandparents. So could you tell me how far you travel to meet your grandparents?
20 kilometers.
Right. How long did she stay by her grandparents? Try
Like,
try to read that. Try to figure that out.
I don't know,
Ali,
like
I think you know you
one
can
and a
answer as
half
well.
hours.
1.5 hours.
Yeah.
Let me see. So that is from 1 to 2:30. You'd be right. 1.5 hours. And let me ask that question, Sasha. How long did it take you to reach your grandparents?
An hour.
An hour. Okay, Ali, I think you catch it by now. In a distance time graph, it shows you how much distance you're covering in X amount of time. So in 1 hour, you reached 20 kilometers. And Aliyah, Aliyah, you there?
Yeah.
So as the time increases, your distance is increasing.
Mm-hmm.
So at
Yes.
a time of 1 hour, what distance did she reach?
20 kilometers.
So how far is she from her home?
20 kilometers.
At 2 hours, how far is she from her home?
20 kilometers though.
So if she's still 20 kilometers from home, did she move?
No.
Okay. So this journey represents her traveling or driving to meet her grandparents. What does this part of the journey represent?
How long she stayed?
Right? And what does this part of the journey represent?
How long it take for she to go home?
Exactly. So, question. They're talking about outward journey and homeward one. Where which one is the outward journey? Is it one or two? Make a guess. Which one is the outward journey?
One.
One, and Sasha, which one is the homeward journey?
Two.
Two, homeward, heading towards home. All right. So how long does she stay with her grandparents? That's the very first question. And Sasha, I believe you answered that quite well. What was the answer?
2.5 hours. Oh,
Is it
sorry, 1.5 hours.
right? 1.5 hours. And that was quite the easy question. Yeah, this is definitely one of the easier topics in maths. Very, very simple, right? So to do that, we just say, oh, and I should explain this, right? Sasha, how did you get 1.5 hours? How you get that? If two big blocks is 1 hour, how much is one big block? Explain to everybody. If
Half of,
a half of an hour, right? So
yeah,
that's a half. So this would be 2.5 hours. At this point here, this point over here is 2.5 hours. You understand? Sasha, here I was saying, if this is two, wouldn't this be 2.5 and this could be three?
yeah,
Yeah. So this is 2.5. What do you think this would be?
3.5.
Okay. But here what we need to do. We need to figure out what one of these small blocks would be. So let's try to do that. So Sasha, if five small blocks is a half of an hour is how much minutes?
30, so 5 divided by 30.
Right. So each small block represents how much minutes?
6.
6 minutes. That's correct. Alia, do you understand how we did that?
Yeah.
Okay, so Alia,
I
so
think so.
how much big blocks it takes to make 1 hour?
10.
10? No. Two big blocks.
Wait. Oh, yeah.
These are
Big
big,
blocks. Yeah. Yeah. My bad.
right? Okay, so then one big block would correspond to half of an hour.
Yeah.
Half of an hour is how much minutes?
30 minutes.
30 minutes. And we how much blocks we have there? How much small blocks?
10. 5 on block.
We have five, right? So you can do it in two ways, but we're going with this one first. So if you're looking at one of the big blocks represents 30 minutes, right?
Mm-hmm.
And how much small blocks makes up the 30 minutes?
5.
Five. So if you have five small blocks and that adding up to 30, how much will one small block gotta be?
6.
Right. Because 5 by 6 is 30, right? And
Yeah.
okay, let's try it a different route. What if we did it like this? We have 10 blocks and 10 small blocks, like I said, makes up an hour. An hour is how much minutes?
60 minutes.
And how much small blocks making up that hour? Remember how much small blocks are making up that
10.
hour? 10. So if you have 10 small blocks and it adds up to 60, how much is one?
6.
Right. So anyhow you do it, you'll get the same answer. So one
Mm-hmm.
small block is 6. And let's verify that. 6, 12, 18, 18, 24, 30. So it's correct. That being the case, let's figure out what this would be one time. So this is 3.5. So that would correspond to 3:30. I would like somebody to figure out what time did the person reach home. See if you all could do that. Well, not so much the time the person reach home. Um, More so the hour. Check something.
6 minutes, or 12 minutes,
You say an hour,
and 12 minutes.
not quite. So if this point over here is 3:30, this point over here is 3:30, then this would be 3:36, and
Oh,
this would be 3:42. So it took the person reached home in 3 hours and 42 minutes. You understand?
yeah.
So let me say that one more time. Each small block represents how much?
6.
Right. So if this is 330, and this is 336, and this would be 342. So you're good.
Yeah.
All right. Keep that in mind, right? Keep that in mind, guys. But anyways, how long does she stay with her grandparents? That's quite simple. She stayed with her grandparents for this duration, the time period for which she was not moving. If you're staying some distance away from home, that means you're not moving. You stay in the same place, right? So that would have been 2.5 minus 1, which is 1.5 hours. Okay, let's do part B. Ali, I want you to try to figure it out. Sasha, you'll correct her if she's doing something wrong. So Alia, read part B for me.
Which journey is the faster, the outward journey or the homeward journey?
Um, which journey is faster, the outward journey or the homeward journey?
Mm-hmm.
All right. If they're talking about how fast something is, right? How fast? What are we talking about?
Time?
You're not wrong.
Well, speed.
We're talking about speed. So we're trying to figure out in which case his speed was greater.
Yeah.
Okay. Do you know the formula for speed?
Distance over time.
All right. So speed is equal to distance over time. Okay. Speed is equal to distance over time. So we need to figure out the speed for the two journeys. Let's figure out the speed for this journey, right? So how long did it take her to reach her grandparents?
An hour.
An hour. And how far away would it?
20 kilometers.
So in an hour, she traveled.
20 kilometers.
So what is her speed then?
20 kilometers per hour.
Right. So this is quite simple for the first journey. So this is for the, let me zoom out so you all could take notes if all you want. Well, I kind of have to take notes, right? So the outward journey, right? So for the outward journey, the speed is equal to the distance. The distance was 20 all over the time. The time was an hour. So your answer is 20 kilometers per hour. All right. Everybody okay with that?
Yeah.
All right. So that's the outward journey. Let's do the homeward journey now. All right. So the speed, again, speed is equal to distance over time. If we are looking at well, we know what the distance is, right? What's the distance earlier for her to go back to home?
20 kilometers.
Yes, the same 20 kilometers. Now, did she take longer or let me see. Let me see if she took longer. So initially it took her 1 hour, right? That was initially. That was to
Mm-hmm.
reach her grandparents. If we
Yep.
compare any time she left and arrived back home, what time is that? We said that this was what time? That was what time? Do you recall how much one of these small blocks is equal to?
That'll be 6 minutes.
Right. So what would two small blocks be equal to?
12.
Right. So what is 330 plus 12?
342.
Right. So
So
we
three
have
hours and No, an hour and 42 minutes.
Right, so we have 2 hours and 30 minutes, right? And over here, at this point, we have 3 hours and how much minutes?
42.
Okay, so how much hours did it take?
1 hour and 12 minutes.
Correct, 1 hour and 12 minutes. So 1 hour and 12 minutes. We need to write that as we need to write it in terms of hours, right? So let's see how we would do that. So we have how much minutes?
12 minutes.
12 minutes. So if we want to write as a fraction, how would you write that in terms of hours? How do you do that? If I told you that it was 30 minutes, what fraction would that be?
A half.
Okay, say you would write 30 over 60, no?
Yeah.
Okay, so if it's 12 minutes, what fraction of an hour is 12 minutes?
That's
All I had to do is put
12 over
a comparison. So 12 over 60. 12 over 60. What is 12 over 60?
That's 2 tenths. So that's 1/5.
1/5. So what I want you to plug into your calculator is this. So 20 all over 1 and 1/5. For anybody that has a sharp, you'll have to plug it in like this. So Sasha, what is 1 and 1/5 as a improper fraction?
6/5.
Perfect. 6 over 5. Matter of fact, you don't even need a calculator. We could do this here. So we have 20 divided by 6 over 5, which is the same thing as 20 multiplied by, somebody tell me fast.
5, 6.
Correct. So we get 100 over 6, and 100 over 6 is like how much? That should be like,
50 over 3.
well, what is ours, a decimal?
16.66 recurring.
So I mean, we could have figured out this like common sense. Sasha,
Yeah.
what is faster? You taking more time or you taking less time?
Taken last time.
Yeah, obviously. So we could look at it and figure it out like that. But the question is asking us which journey is faster. We want to provide extra substance, so you're directly going to compare these speeds. So you need to do that. And in doing so, you're answering C as well. You all will see what I mean by that. But Sasha, you understand why the homeward journey is slower
Yeah.
because it's the same distance. They just took more time. And if you're taking more time, it means you're traveling at a slower speed. And we saw that. The outward journey is 20 kilometers per hour, and the homeward journey is 16.66 kilometers per hour. That's definitely slower, right? Yes. All right, so you all could take notes. Take some notes quickly. So, Aliyah, we had to say which journey was faster. So, the what journey was faster?
The outward journey was faster.
Right. Cool. Outward journey was faster. Right. So copy this down quickly. I would like you to also do the graph. If you can't see the graph properly, there are pictures on WhatsApp.
Okay.
Oh, shucks, I'm sorry there. Let me just get back to the screen. Okay, great. So, Sasha, I'm going to ask you a question. Where do you think the speed is greater? Where there is a steeper gradient or a more gentle gradient? Remind me, do you know what gradient means?
What is it?
Say that again.
I can't hear properly because you're sticking.
All right, I asked which gradient would mean faster? A steeper gradient or a more gentle gradient?
A gentle gradient.
No. A gentle gradient means that the steepness, okay, so gradient means steepness. What would you say is steeper? This or this? One or two?
One.
One. Because if you was driving until that'd be more trouble for you to go up that.
Yeah.
Okay, so let me ask that question. Which one of those lines takes less time? The first line or the second line? We're trying to reach 20 kilometers. Which
The
one?
second one.
The second one take a lot more time. So you're looking out for the steepness of the graph. They could ask you to explain why in terms of steepness. So I'll make a note on that as well. So Sasha, anytime I say gradient, I'm referring to the steepness, right? A gentle gradient means it's closer to being horizontal. And if you're horizontal, what do I mean? In a distance time graph, if you're horizontal, what does that mean? What did it mean? Like from the graph, what did we infer from the graph? What did we say about this portion of the graph?
There's just one place.
Okay, and if you're in one place, what I mean about speed?
We're standing still.
So, where's your speed? If you're staying still, where's your speed? If you're not moving,
It had zero.
zero, correct. So the gentler the gradient gets, the speed decreases. The steeper the gradient, the faster the speed. I'll make a note of that. So yeah, just recap what I said. The first thing, what can I give away? The fact that the first journey was faster than the second journey.
How steep the line was?
I said that, and was he even simple reason?
The gradient.
No,
Well,
steepness means gradients. That's what steepness means. Steepness is gradient. So Ali, I want you to think, other than the gradient being steeper or not as steep, what is something we could immediately look at and tell if one of them faster than the other?
the size of like the space
What do
in
you mean by
between.
this space? Yeah, to elaborate. What do you mean by this space?
like you see the space like in between the the black line that you draw.
Okay, you gotta tell me what that is. So if we taking a
Um,
reading on that axis, what we measuring?
the time.
Right. The time. So that's what we have to see. We can look at the time it takes. In both journeys, is it the same distance?
No,
No.
wait. In both journeys, the same distance. Yeah, distance. Yeah,
Explain why.
because she like from her home to she grandparents is 20 kilometers and
You going good? Earlier.
just now.
Okay. So the key observation is number one, the time, the time for the outward journey was
Sorry about that.
it's okay.
Bryce come and he start to
The surveyor.
yeah.
Hmm. All right. So yeah, see what you were saying.
Um,
So that
from her
so
home
yeah, from home,
to her grandparents, it took her 20 kilometers, and
you
she
wouldn't you
remained
wouldn't say it took her 20 kilometers. When you
well.
if you're talking about taking, you talk about time.
Okay,
Talk about distance. Talking about distance here.
yeah. Um, it was 20 kilometers away from her home.
Right? So from her home to her grandparents is 20 kilometers. And that concept would apply whether she's going to her grandparents or she's leaving her grandparents. The point is, from her home to her grandparents is 20 kilometers. So the return journey and the to journey should be the same distance. So if the distance is the same, what's the only thing that would affect the speed?
What was that?
So the distance is the same for both journeys. What's
Yeah.
the only thing that would affect the speed? So if the distances are the same, what is the only thing then that will affect the speed?
Um, hmm. The
Yeah, like we're going. Say that again. Say it.
the
Say that. Say what he was gonna say.
time,
Yeah, look at the equation. What's the equation for speed?
distance over time,
So if the distance is the same, what's the only thing that could change in that equation?
the time.
Yeah. So the time. Time is the main thing. If the distance is the same, if you take longer, then your speed was less, right? So that's one of the observations, and that would correspond to if you take a longer time, would that mean the gradient is steep or gentle?
If you take a longer time,
Yeah,
it could be steep.
no.
No.
A steep gradient means that you reach a destination in very little time.
Uh-huh.
That's why it's steep.
Okay.
Watch.
Okay. Yeah.
That is steep.
That's
And that means you reach there like in no time at all.
okay.
A gentle gradient, look at this. That would take a lot of time.
Yeah.
So let me write that down. What does a steep gradient imply? A steep gradient means faster or slower.
Slower. No, faster. Oh my God. Sorry.
So what exactly is a steep gradient? A steep gradient is a gradient that goes up really quickly. In other words, the angle, the angle between the horizontal axis is kind of large. When we talk about okay, what is the gentlest the gradient could get? Ollie from Trinidad, Ollie should know where's a good road and a bad road. Alia, where's a good road? If you're driving a car, how you want the road to be?
Smooth.
Smooth and what? Like you want to be driving like that? Imagine you had to go up that.
No.
You want the road to be smooth and flat, horizontal. You don't want to be climbing up no hill and thing.
Yeah.
So the gentlest the gradient could get is horizontal. Means like that. That's the gentlest the gradient could get. What's the steepest the gradient could get? Let me see if I can figure that out. If this is the gentlest the gradient could get,
Vertical.
yeah, vertical is the steepest they could get. Right? Perfect. So a steep gradient means faster, and a gentle gradient means slow, right? So what I did here, um, this is the steepest, and this is the most gentle, right? I hope you all have that covered. Does everybody understand?
Yeah.
Okay, so Alia, you see how you're saying you understand? When you do an actual question, then you will see if you truly understand. That applies to everybody here. Because only when only do an actual question only to see if you understand anything, right? So yeah, copy that down. Sasha, copy that down. Right? Sasha, I want to ask you something. Which gradient is steeper? This gradient or this gradient? One or two? Which one looking steeper? One or two?
One.
One is steeper because steeper means what does steeper mean in terms of speed? Steeper, faster or slower?
Slower.
No, steeper means faster. If something is steep, okay, think of steep as you having to drive up a mountain or something. When we talk about steep, we're talking about a very high rise. Those are steep, right? Um, that is what steep means. A gentle gradient is something like that. Again, think of driving. Sasha, which one would be easier to go up? One or two? One or two?
Two.
Right, because 2 is a gentler gradient, is gentler. 1 is very steep. If it is steep, if it is steep, that means it's faster. And the reason why it would be steep is because it's taking less time. So steep means faster. Gentle means slower. So again, Sasha, which gradient is steeper? 1 or 2?
1.
1 is steeper, right? If you look at it, 2 is a little more gentle. Kind of hard to see, but 2 is a little more gentle. Yeah. So you have everything copied down? I didn't hear. I saw you unmuted.
Almost.
Almost, all right. Aliyah, you let me know when you have everything down.
I finished copy them.
Okay, cool. I'll just wait for Sasha and Kira. All right, Sasha, you have it down?
Yeah.
All right. So, Sasha, wait to read part C. Read part C.
What was her average speed on the outward journey, on the homeward journey, for the total time she was cycling?
Okay. So, Sasha, which one out of the 3 did we complete so far? I want you to tell me which out of the 3 did we complete so far?
1 and 2?
One
Part
and
1 and
that's
2?
correct. 1 and 2. Right. So this is technically C part 1 and part 2, right? Okay, so we need to figure out part 3. So Sasha and Aliyah, they're saying they want me to figure out the speed for the total time she was cycling. Could you all figure out? I want Aliyah to tell me how long she was cycling for. See if I can figure that out. How long was she cycling for?
20
Like the
kilometers.
total time she?
Aliyah, did you just now say 20 minutes?
No,
You
No,
said
she said 20
20?
kilometers.
Okay. If I ask you how long,
time. That's
time,
time.
that's time. What's
Is
the
it 2
duration?
hours and 12 minutes?
2 hours and 12 minutes. So let me see. So it took her, so she cycled for 1 hour to reach, and then she cycled for, this is 2.5 hours, and this is 3 hours and 42 minutes. So let me see. So the time here, so we know what the time here is, right? Sasha, what was the time here? It was 1 hour and 12 minutes, right?
Yeah.
Right. So if it took her 1 hour to cycle to reach your grandparents and 1 hour and 12 minutes to reach back home, then altogether she cycled for 2.5 hours, like not two and a half,
Two, hou-
two
two
hours
hours
and
and
12 minutes.
12 minutes.
Guys, did she cycle for this period?
No.
No, she didn't. So if you said that she cycled for 3
No.
hours and 42 minutes, you'll be wrong. She actually cycled for 1 hour plus an hour and 12 minutes. And what was the total distance she traveled? So she cycled to the grandparents' house and to home. So what was the total distance she covered?
40.
40, that's correct. So is it possible for me to figure out the the average? Is it
Yeah.
possible for me to figure out the average speed for the total time she was cycling?
Yeah.
All right, let's do that. So the average speed for the total time. Right. So just remind me, guys, how long did she spend cycling? Alia, remind me. How long
How
did she
long?
spend cycling? How long did she spend cycling?
Um, an hour and 12 minutes.
Right. An hour? No. She took an hour. She took an hour to reach her grandparents. So that's 1 hour.
Right.
And
Oh,
then she
two
took an
hours.
hour an hour and 12 minutes to reach home.
So 2 hours and 12 minutes.
Right. So I'm gonna say she cycled for 1 hour plus 1 hour and 12 minutes. So she cycled for 2 hours and 12 minutes. What is that as a fraction? If I wanted to write that the answer in terms of hours, how would I write that? That would be two and what fraction of an hour is 12 minutes? Sasha, I want you to answer that. What fraction of an hour is 12 minutes? Yes, so Sasha, how much minutes we have in an hour?
60.
So we want to write 12 minutes as a fraction of an hour. So that'll be what over what?
12 over 60.
Right? And that simplifies to what does that simplify to?
5.
12 over 60 is 1 over 5. You're thinking about 60 over 12. But nah, it's always okay. So is think about it like this: it's 12 out of 60, so it'll be 12 over 60. So 12 over
Oh,
60.
yeah. I put it around to divide it. My bad.
No, do that. Do it like this one time. So 12 into 12 is 1. 12 into 60 is 5. So we have 2 and 1/5 hours. All right, we have 2 and 1/5 hours. And we know that the total distance she traveled was 40 kilometers because she had to travel to her grandparents and to. So the formula would be is distance over time. So the distance is 40 and the time is 2 and 1/5. Right? I want somebody to plug this into the calculator. So 2 and 1/5 is what is our improper fraction, Sasha? What is 2 and 1/5?
11 over 5.
Yeah, 11 over 5. Right. So somebody plug that into the calculator and tell me the average speed.
That's 18.18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18. 18.
All right. I'm gonna allow you all to think. There's another way I could have answered that question. Let me see. Let me see how well you could critically think. Where's another way I could answer that question if I didn't want to do this working? Let me see if I could figure that out. So try to figure out another way we could have figured out this. Let me see if I could figure that one out. Yeah, so what I'm asking is there another method to figure out the average speed for the total time cycling? Sasha, you have any idea?
No,
Nah? Try to figure it out. So they're asking us the average speed for the total time cycle. What does average mean? If I tell you you get 10 in a test and Aliyah get 9 in the test, how you find the average? Sasha,
just add up the two and divide it.
okay, divide by what?
2.
Okay, so look at this question. See if you can apply that. So we calculated using this method, right? See if there's another method. See if there's any possible method that I could use.
We could add up the 20 kilometers per hour and the 16.66 kilometers and divide by
Excellent.
2.
Yep, that's exactly it. Because what we have there, we have the speed to go and the speed to come back. So we just had to add it and divide it by 2 and you'll get the answer. Right, let's try it. So the alternative method would have been, yeah, I want to let you try this. It's supposed to be same answer. For some reason it'll be a little higher. That's strange. That's weird. Oh no, I put 18. That would be 16. Yeah. Any other plug and listen to the calculator?
You get 18 point.
I get 18.33.
Okay, that's because we run off a little bit.
Yeah,
Here what? I want to let's put 18 point. Try this. Try putting that. Make sure this in brackets, yeah? Make sure that's in brackets. Let's try that. So Sasha, you gotta put open brackets 20 plus 16.666666. You gotta close the brackets and then press divide by 2. We realize again a very close answer, right? That's because you're more or less doing the same thing. It's just the fact that we're using a rounded up answer. That's why we're not getting the exact same thing. Right. You get 18.33, which is about the same thing. But both of you all understand the two methods, right? Let me know if I understand that.
Yeah.
Ali, are you okay?
Yeah.
You sure?
Yeah.
All right, I'm gonna give you that question now.
Okay.
Yeah.
Not a hard one though.
Hmm.
That's you gonna give me that?
But unless all they want to draw a graph. It's an easy question. You just have to draw the graph. Try it. Try that question then. It's an easy graph. Yeah, so I want to let's try this. Sasha, you think you have an idea as to what to do? I never drew a graph with you all. Um,
Probably not.
you don't know, you don't think you can figure this one out? I think you could. So let me read the question. I'll give the question I read.
A motorist traveling at a steady speed along a main road passed at a point A at 12 noon. At 2 p.m., he stopped at a cafe B, which is 160 kilometers from A.
Okay, so
And
let me understand what's going on there.
okay,
So if we starting from E at at E, what time is it at E?
um, 12,
Right. So Sasha, keep that in mind. So you're starting from E, right? And they said it was traveling at a steady speed. What would a graph of what would steady speed look like? Would it look like this or would it look like that? Which one? The curve or the line?
You're lying.
Yeah, the line. I never see no curve and thing. My students gotta deal with that.
You're lying.
Yeah, you see the line. So what's going on here? We starting from a point A, and that is 12. Then we go in at a steady speed until we stop off at 2 p.m. Right? Everybody with me? Some of you understand that so far.
yeah,
Now at 2 p.m., where did he reach?
B,
B. So this would be point B here. And they're saying that B is 160 kilometers from A. So if we count in this distance as 0, what distance would it be here?
160.
160 kilometers, that's correct. And at 3 p.m., he continued his journey. So let me ask you a question. If at 2 p.m. he reached at B, and they're saying that he left at 3 p.m., what does that mean?
He stayed at Cafe B for an hour.
Right. So we could show that. Um, he continued his journey at the same speed to C, which is 30 kilometers from B. Okay. So 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 they're saying that he continued his journey at the same speed to C, which is 30 kilometers from B. All right. So he reached C. So if this is B over here, right, and they are saying that C is 30 kilometers from B, what do you all think? What do you guys think the distance would be over here? Make a guess. So Sasha, check what we're saying. We're saying that C is 30 kilometers from B. So if this is B over here, if B is 160
190
kilometers,
kilometers.
yeah, that'll be 190 kilometers. And then it's saying he then continued at a steady speed of 100 kilometers per hour. It don't really specify when he's stopping though, which is weird. Hence or otherwise, find the time at which the motorist arrived at a point D, a distance of 350 kilometers from A, measured along the main road. Okay, this is a nice question. So, Sasha and Aliyah, Aliyah understand how the graph looking so far, right? It makes sense?
Yeah.
Okay, Sasha, it make sense for you, right?
Yeah.
Okay, and so he continued the journey at the same speed to C, which is 30 kilometers from B. So we have that over here, 190. They're saying he then continued at a steady speed of 100 kilometers per hour. Hence or otherwise, find the time at which the motorist arrived at a point D, a distance of 350 kilometers from A. Okay, so Sasha and Aliyah, if point D is 350 kilometers from A, wouldn't that be like up here,
Yeah.
right? And I would say that's something like that. That's probably what we would have. So this is like a hard question. It's a hard question. It's probably harder than the last question. Yeah, sorry, I didn't make it easy for you.
No.
Didn't really make it easy for you. So let me try to do this question, right? Um, let me try to do this question on the board. So a motorist traveling at a steady speed along a main road, wherever, taking 2 centimeters to represent 1 hour on the x-axis and 2 centimeters to represent 50 kilometers in the other, they want me to draw a graph. So let's do that. So Aliyah, what's the scale on the y-axis?
Um,
You try to figure that out. What kind of graph is this? If you don't know, you can ask Sasha.
Distance time.
Right. If it's a distance time graph, what is going on the y-axis?
the distance.
Right. Do you think it makes sense to put 2 centimeters that represents 1 hour on the y-axis?
No.
No, we should put 2 centimeters is 50 kilometers. If we're talking about distance, talking about kilometers.
Yeah.
So I'm gonna do that. I think 11 is safe enough. Let me see. So if we say every two is 50, then this could be 50, this could be 100, 150, 200. Now we're gonna need more. We need more because we had to go up to how much? What's the distance we have to go up to, guys? What is the distance we have to go up to? Could somebody tell me? Look at the question. What is the distance we have to go up to?
160.
160.
160 now. Hence or otherwise, reader, hence or otherwise.
Oh, 350.
Yeah, 350. Let me get some actual graph here. Let me get actual graph. Yeah, get a graph. Right. Okay, nope. Wonder if I grab a graph. Yeah. Check. Okay, we do the question on a new page. All right. All right, so let's go. So on the y-axis, what we call on the y-axis? Just remind me, guys, what are we gonna call the y-axis?
The distance.
Okay, y-axis, we call it the distance. And what are we calling the x-axis?
Time.
Yeah. And the distance is measured in what? What is the distance measured in? You need to say that.
Kilometers.
Right. There's the distance in kilometers. Over here. Right. Give me a moment. I don't like how this. No, I don't like this. Let's fix this real quick. Come now. Give me un momento. All right, we're gonna call this the time. And what are we measuring time in here? Aliyah, what are we measuring time in?
Hours.
Hours, correct. So on the y-axis, every 2 centimeters is 50. So Aliyah, way to count. This is 50.
100. 150. 200. 250. 300, 350,
All right, so let me just go one level up just in case.
400,
That's it. Okay, cool. All right, time for the x-axis. They're saying that every 2 centimeters is 1 hour. Okay, so 1, 2. Okay, that's not exactly what I mean. You're not gonna do it like that, right? Aliyah, according to the question, what time are we starting at?
12,
We starting at 12, right? So 12, and they said that every 2 centimeters is 1 hour. So what's after 12? It was 2 centimeters, right? Yeah, 2 centimeters. So what's after 12? If every two is 1 hour, what's 1 hour after 12?
1,
Right? Then 2.
3, 4.
Okay, cool. 0. All right. So a motorist traveling at a steady speed along a main road passed a point A at 12 noon. At 2 p.m., he stopped at Cafe B. Right? So at 12, so look carefully at how I'm gonna do this. Um, gonna use red. So Aliyah, we started at what time? What time is point A?
12,
12, and that's point A. And Sasha, we're going, we're traveling from 12 to what time? At what time we stopping off?
2,
Right. And what distance am I going to? I want somebody to answer that. What distance are we going to? So in a distance time graph, you need to know the distance and you need to know the time.
You're going to
160.
160 kilometers.
Correct. That's correct. So this is A. And we're going 160. So guys, I have a question. If this is the scale we are using, could somebody tell me what one of these small blocks would be equal to? I need to know that.
5?
5? Let me see if
I
that's
don't know.
5, 10,
No.
15, 20, 25, 30, 35, 40, 45, 50. Still think you're
Oh,
wrong?
yeah. No.
Correct. All right, so each small block is 5. And if you think about it, we have 10 small blocks, so 10 into 50 is 5. Say good. So where would 160 be then? Where would 160 be? How much blocks above 150? Sasha, tell me. If every small block is 5, how much more blocks from 150 would 160 be? Come on, guys, all I have this. So Sasha, remind me, how much one of these small blocks is?
5.
Okay, so and we want to go to 160. So how much more we
Oh,
will
it's 2 blocks.
how much blocks?
2?
2. So that's over here.
Yeah.
That's it. So let's try to understand what we're doing, right? So we starting at 12, right? And we stopping at what time? What time we stopping at? Remind me. The question is on the chat.
2?
We stopping at 2. And when we travel for 2 hours, what distance do we reach away from A?
160 kilometers.
Correct. So your graph not gonna look like this, right? It's not gonna look like this. It's going to look like this. Tell me if you understand that.
Yeah.
All right. These are different color. Alia, you understand this?
Yeah.
All right. So, Alia, if that is the case, can you find the speed for that journey? Do that for me. Find the speed of that journey.
Okay.
And Sasha, what point is this over here? When you reach over here, where did you reach? So at
Point A.
point A,
Wait, no, no, no. That's point B.
that's point B. And how long do we stay at point B?
Oh, hold on. About an hour.
About an hour, yeah, to be specific.
Well, for hour.
An hour, right? An hour. So what is an hour from 2 hours? What imagine imagine you're starting at 2 o'clock. What is an hour from 2 o'clock?
3 o'clock.
Right here. All right. So if this whole line over here, so like if the flat line represents B, they said that the person leave it, they said that the person leaves B and it goes to where? Where does the person go next?
It takes a journey at the same speed to C, which is 30 kilometers from B.
Okay, right. So we need to figure out where 190 is. Sasha, where would 190 be? See if you can figure that out. How much blocks down from 200? How much blocks down from 200?
2.
2 blocks down because each block is 5. So 10 minus 200 is 190. So that's over here. Aliyah, did you figure out the speed for this journey?
Um, and it could be 160 divided by 2,
Correct. So what was that?
80 kilometers
80 kilometers. What? You had to tell me.
per hour.
Right. So speed from A to B is 80 kilometers per hour. You good with that, right?
Yeah.
Cool. And at 3 p.m., he continued his journey at the same speed to C. So if he continued his journey, so he's leaving the cafe. It was a cafe. Yeah, it was a cafe. So he arrived at the cafe at 2 p.m. and left the cafe at 3 p.m. and he continued at the same speed, right? So Aliyah, they are saying he continued at the same speed. So what was the same speed we talking about?
The 160.
160,
No, sorry, the 80 kilometers per hour.
80 kilometers per hour. Right.
Yeah.
So we already know that to go from B to C, it needs to be the same speed, right? It's the exact same speed. Now, this is the tricky part. This is the tricky part. And I'm not sure if Ollie could figure out this. So Sasha, we know we want to reach a distance of, according to the question, it said that C is 30 kilometers from B. So we need to go 30 kilometers, right?
Yeah.
So we need to travel 30 kilometers. So that's one of the facts, right? To go from B to C is 30 kilometers. And what are they saying in the question? Sasha, what are they saying in the question? He continued his journey
His journey was at the same speed.
at the same speed, right?
See?
So we know that the distance is 30 kilometers. What is the thing we don't know? We know the speed had to be
The
80 kilometers per
time,
hour. We don't know the time. So that is something we need to figure out. So if we have the distance, and we have the speed. Remind me, which formula would we use? Let me just neaten up everything, right? So A to B. Wait, let me just neaten up everything, guys. So from A to B, the speed. So Alia, what formula did you use to calculate speed? Just remind me.
Distance over time.
Okay, so you said speed is equal to distance over time.
Yeah.
What was the distance from A to B?
160.
And what was the time it took?
2 hours.
So what was the speed?
80 kilometers per hour.
Okay, all right. So we understand that. Now we need to go from B to C. And what are the facts about B to C? What do we know? Tell me the facts. What we know for sure.
Um,
Come on, think. You could do this. What do we know about B to C? Well, what
it
do we
was the
know about
same
our journey?
speed.
It was the same
It was the
speed.
same speed.
So what do I mean?
Um, the speed is equal to 80 kilometers per hour.
What else we know?
Which is 2 kilometers from B.
So how far are you traveling to go from B to C?
30 kilometers.
So where's the one thing we don't know? Where's the one thing we don't know? We have speed and we have distance. What,
We
we don't-
do have time.
what formula has speed, distance, and time in it? Hmm.
To find time, it could be time is equal to um,
Sasha, what
12.
formula? Sasha, what formula would we use? What formula do you know? What formula has speed, distance, and time in it? Where's a formula you know have all three in it?
um, time equals distance over speed.
Yeah, that's it. That's it. Um, Alia, let me show you an easy way to do it. Anytime you have a situation like this, think of it like you're cross multiplying, but you only multiply one thing. Let me show you what I mean.
Mhm.
Ideally, if you're cross multiplying, you go say one by distance and speed by time. Hence,
Yeah.
well, you could do it halfway, right? And it will still make sense. So what you could do
Yeah.
if you wanted, you could swap speed and time. Let me show you how that making sense. Imagine if I had 1 is equal to 2 over 2. Okay, if I say 1 is equal to 2 over 2, if I swap the 2 and the 1, so now I'm saying 1 is equal to 2 over 1. That's still correct?
Yeah.
Yeah, because what's 2 over 1?
2.
2. So anytime you have a situation like this, right? Anytime this applies to anything. Anytime you have an equation like this, and this goes for transformer calculations in physics, when you had to do like so like when you're doing ns over np is equal to vs over vp, like we just say you want to find for vp, all you had to do is just swap position with ns. That's all. So Aliyah, I need you to understand this. If you're confused, tell me. All I'm saying is you're swapping the speed with the time. And this only works
Okay.
when you have a when you're looking like this.
Okay.
It's basically cross multiplication, but we only cross multiplying one thing. I feel like you're a little confused.
No, no, I understand now.
So all we doing, we swapping the speed and the time. So if I want to figure out time would be equal to what?
Distance over speed.
Right, distance over speed. All right, so let me do this real quick. What is the distance?
30
Um,
kilometers.
time
What's the time? I mean, sorry, not the time. What's the speed? What's the speed?
80.
So what is 30 over 80?
3/8, which is 0.375.
Hmm. All right, 0.375. And what time is that? Is that time in minutes, hours? What is that? Could somebody tell me? Sasha, do you think that's in hours or seconds or minutes? What do you think? What would make the most logical sense?
Hours.
Hours. Think about that. Imagine if a car so fast, it could reach 30 kilometers in 0.375 minutes. That's crazy. That's that's crazy. Sasha, you watch F1 racing or?
Sometimes. But yeah.
Yeah, that faster than the
I
F1.
don't need to watch it. I have a Maniac who is drive right at home in my house currently.
That's true. But Alia, you see how it makes sense to say is hours? And again, what units did we use? What units did we use here? We use kilometers on.
Hours.
So it makes sense that when you calculate, the time will be in hours. So here what we're gonna do, right? We're gonna convert this to minutes. Let's do that. Alia, why do you think we want to convert it to minutes?
Because it's a decimal.
Yes, a decimal. So if I wanna convert that to minutes, what do I do? So what is
Uh,
0.375 of an hour? That's what you have to do. What is 0.375 of an hour?
you multiply
We can multiply that by what?
60.
Right, because hours to minutes is just multiply by 60. So
Mm-hmm.
0.375 by 60 is,
22.5.
right? Yeah, this question will not definitely kill all of it. That's how we do it in class. So if someone just come, they know what to do. Okay, so to go from B to C, we know you had to travel 30 kilometers more. And how long is that taking? So Sasha, now that we do the maths, how long it taking? How long it taking to go from B to C? If you're going at the same speed, which is 80.
22.5 minutes.
Right. So here what we need to do. We need to figure out how much one of these small blocks is equal to on the x-axis. So I know this looking kind of confusing, right? Because it's here in 0 to 12. Don't bother with that. We know that on the x-axis, every 2 is 1. Right? So Sasha, on the x-axis, every 2 is 1. Every 2 is 1 over. Oh, um, I might have erased that.
One of the,
I erased it. I'll just fix that.
would it be one of these small cubes is 6 minutes?
6 minutes, as we're saying. Let me check. So 1 hour, 1 hour is 60. That's correct. 6 minutes. Right? So how much should be 22.5 then? We gotta kind of estimate that. Right? So Aliyah, you understand what she's saying? Since since 10 blocks is 1 hour and 1 hour is 60 minutes, then one of these small blocks would be 6 minutes. You
Yeah,
understand?
yeah.
Okay. So let me see. So we at B and we want to go to C. Now we know for a fact We know for a fact that C is 190, right? We know it's 190. So like that'll be somewhere over there. And we're saying that it is 22.5 minutes from 3 o'clock. Right? So we need to figure out where that would be. So Aliyah, count with me. This could be 3 hours on
6 minutes
something
at
I'm looking a little fishy. Well, let me continue. 6 minutes. This could be
12 minutes, 18, 24.
oh, so 22.5 gotta be in the middle.
Yeah,
Yeah. You understand now?
yeah,
Right. Matter of fact, if you add 18 and 24 and you divide by 2, you get 21. But since we had this since they gave us this scale, we had to like estimate, right? We had to
okay.
estimate. So this is 5, sorry, not 5. 6, 12, 18, 24. So somewhere over here. All right. So anybody confused by that?
No,
No? Um, what about you? What's I gotta say, Amy? What about you, Alia? Are you confused by that?
No,
All right, so you understand that it go into the kilometers more, which is the 190, and it's we stopping at 22.5 minutes later.
yeah.
Okay, say good. Awesome. All right, let's read the rest of the question. He continued his journey at the same speed to C, which is 30 kilometers from B. He then continued at a steady speed of 100 kilometers per hour. Okay, so Sasha and Aliyah, they are saying he then, so like this over here is C, right? We know over here is C. Did he stop off by C? Are you all seeing anywhere any question that he stopped off by C?
No,
No, he did not stop off by C. They said he continued his journey at the same speed C, which is 30 kilometers from B. He then continued at a steady speed of 100 kilometers per hour. Okay. So, remind me, guys, what is the speed over here? What we know the speed is? Can somebody remind me? What speed was he driving at from B to
80
C?
kilometers.
But now he going what now? According to the question, they said, they said, he continued at a steady speed of,
100 kilometers per.
so what do I mean? He increased in his speed, decreased in his speed.
Yeah, he increased in. No.
Yeah,
Oh, yeah, yeah, yeah.
yeah, right? And it's saying, hence or otherwise, find the time at which the motorist arrived at a point D, a distance of 350 kilometers from A measured along the main road. So, I'm trying to figure out what point D is. So, let me write down a couple of things. Guys. So, from C to D, let's write down the facts. Okay, do we know what the distance is from C to D? See if I could figure that out. If C is 190, if C is 190 and D is 350, what's the distance from C to D?
190 minus
350 minus 190, right?
350.
Yeah, where's 350 minus 190? What is 350 minus 190?
Yeah,
Yeah, but what is 350 minus 190?
160.
Right. So we know the person has to travel 160 kilometers. And what speed are they going at? What is his speed? Alia, remind me, what is his speed? They said that the person then went from C to D at a steady speed of
Um, a steady speed of 100 kilometers
per hour.
per hour. Per hour.
So what's the only thing we don't have? We have the distance, we have the speed. What are we missing?
The time.
Time. We know what the formula for time is?
Yes.
What's time?
Time is equal to distance over speed.
Time.
Yeah. Time is equal to distance over speed. Right? We know that the distance is 160 and the speed is 100. So what is 160 over 100, guys?
1.6.
1.6. And that is 1.6 minutes, 1.6 seconds, 1.6 days, 1.6 months. What's that?
Hours.
Yeah, that's hours. Right. So, Ali, you're okay with what we're going on so far, right?
Yeah.
Okay. We nearly there. We nearly there. So from C to D, it took how much time to reach D? So Ali, I hear what I'm asking. From C to D, how long did it take to go from C to D, according to our calculations?
From C to D,
Uh-huh.
1.6 hours.
Right. Here, well, let me convert up that 0.6 hours to minutes. So zero point 0.6, that should be easy. 0.6, that'll be 60 over 100 by 60th,
Yeah.
right? Because 60 over 100 is 0.6, and 60 is how much minutes it have in an hour. So this one, this would cancel off. 6 by 6 is
36.
right. We have 1 hour and 36 minutes. So Aliyah and Sasha, I don't think I'll have any idea what we're gonna do with our 1 hour and 36 minutes. What am I gonna do with that? I'm trying to figure out where D is.
So you're
Yeah.
adding it to the
Right.
time where he at now?
Hmm? Tell me, Aliyah.
You're adding it to the time where he's at right now?
Correct, because that's C. And I want to go to D. And I know that I have to reach a distance of. What distance do I have to reach? Remind me. How far is D?
100. Um, no, wait.
From here,
100.
100, no.
Wait, the distance that would be
Like, what distance we gotta end up at? Like, you know how I drew, like, we had to go to 190, so I draw the line, because that's what we had to reach to go to C. Um, what's the final distance? Check the question again. If we are at D, what distance we would have had traveled?
350.
350. So 350 is over here. Not quite 350. Right, that's 350. Um, and we know that it's gonna take 136 minutes from C, right? So let's see. C C is 3 hours. Remind me. Aliyah, C was 3 hours and how much minutes? Do you recall what time that was?
That was 22, was it? No,
22.5.
22.5.
So that's really three, I wouldn't say 22.5, but yeah, that's really 322, basically. You don't normally see decimals, right? But that's 322, right? You understand? That's the time, like 3:22 p.m. But if it's less confusing, I'll just write it as 3 hours and 22.5 minutes. That should be less confusing. And I need to go an additional 1 hour and 36 minutes. So if I add 1 hour and 36 minutes to that, what would I get? Tell me, Alia, what is 1 hour and 36 minutes plus 3 hours and 22.5 minutes?
Um, that'll be
So 3 plus 1
4
is
hours and 58.5 minutes.
right. So the person basically reached D at what time? If we were to like round up, like to the nearest hour, what hour the person reach D? Guys?
What was that?
So what time the person reached D? So 4 hours and well, it's really
So
4:58 p.m.
4:58?
It's really
Yeah.
4:58 p.m. So that would be like 458.5. That's basically like right here. Okay. Wait. If this is 5, that'll be 4. Well, let me count. Well, we know that this is 30. This would be 36, 42, 48, 48. Um, wait, I have another moment there. 36, 42, 48, 54. Yeah, that's
Mm-hmm.
54.
Mm-hmm.
And yeah, so that'll be dead smack in the middle, if not closer to 5. But since they gave us a scale, we just had to like estimate, right? Just have to estimate. So I'm gonna say like right here. That's what I'm gonna say. And that point is D. That's it?
Mm-hmm.
Yeah. So the question was, hence or otherwise, find the time at which the motorists arrived at point D. So the motorists arrive at point D at basically, if we round that off, it'll be 4:59 p.m. You understand?
Yeah. Use your rounding up.
Yeah.
You wouldn't really say 58.5 million. You wouldn't say 4:58.5 p.m. Might say 4:59 p.m. Right, so that's it. That was a tough question. Yeah, that was a tough one. I will copy this down for homework. So I got better copy down. All right. I did start class late. That being said, I want to let you try this question.
Uh, okay.
Yeah, that question should be easier. Try something fast. Try a little something, something. You guys got this for sure. For sure. Alia, we think at our last question.
The last one we do,
Yeah.
it wasn't bad.
Hear what? My advice is always look at what you have and what you don't have. That's my advice. Always.
Okay.
So I'll give you only 10 minutes on this question. Take 10 minutes. Actually, I'll give only 5 minutes for the sake of time. See what they can do in 5 minutes. Realistically, I don't think any of they can finish the question in 5 minutes. But just see what you can do in 5 minutes. Yeah, any other figure out anything so far?
I think I do the first bracket. I don't know.
All right. So the first one is saying, so you have two journeys, of course. You have A and B, right? So the travel graph shows the journey of two buses from town A to town B. The first bus leaves A at noon, and the other bus follows later. So you have two journeys. Okay. Use a graph. Find the speed of the first bus during the first hour. All right, that's easy. The average speed of the first bus for the second part of the journey, that's easy as well. The average speed of the bus for the whole of the journey, again, that's easy, right? Now this question really easy. It's an easy question, man. I've got this. All right, time is up. All right, I want everybody to send me what you have so far so I could correct it. I don't care if you didn't finish, just send me what you have so far. Yeah. Um, Sasha and Aliyah, send me what you all have so far.
My answer like not making sense. So
Okay, we still start something. I'm waiting, guys. Send me. Let's see what they have.
I'll send you something. I don't know if it 100%.
All right. Well, let me do the questions quickly. All right, so Sasha and Aliyah, well, it's on mute, right? So, Aliyah, read the question from me fast. Fast, fast.
this travel graph shows the journeys of two buses from town A to town B. The first bus leaves A at noon and the other bus follows later. Use the graph to find A, the speed of the first bus during the first hour, B, the average speed of the first bus for the second part of the journey, C, the average speed of the first bus for the whole of the journey, D, the time at which the second bus leaves A and the time it arrives at B, E, the average speed of the second bus, F, the time and distance from A when the second bus passes the first.
All right, let's go. So, first one, the speed of the first bus during the first hour. So, the first bus leaves at noon. So, we're talking about this graph here. So, at 1 hour past noon is 1 o'clock. So, that's quite simple. The distance is 60 and the time is 1 hour. So, the answer for the first one, part A, the speed, that would just be equal to 60 over 1, which is 60 kilometers per hour.
I get that.
Right? Nice. Sasha, you get that?
Nope.
You didn't get that? Nah.
But no, but I understand it.
What? 60 hours? What? What?
Listen, listen.
What? Where the hell? 60 hours? I mean 60 minutes? But
I
we
mean
want it in
60
hours.
minutes, but
We
that's
want it in
both.
hours. What the G?
Yeah, my bad.
No, we're dealing with hours here. Okay, the next one. The average speed of the first bus for the second part of the journey. The second part of the journey will be over here. Aliyah, you recognize that? Or no? Aliyah?
Yeah, yeah.
Okay, so that'll be from 1 p.m. to what time?
To
So we have, so again, 10 blocks is 1 hour. So one small block is 6.
so 2:12.
Yeah, that'll be 212. So what's the time?
An hour and 12 minutes.
Right, and what's the distance? Let me see. To figure out the distance, that would be 60. You're going from 60 to what? 60 to what?
100.
So what's the distance?
40
Right, so
kilometers.
the speed here would be equal to 40 all over. And that would be that's from 1 p.m. to 2:12 p.m. What's the time there?
212. So 1 hour and 12 minutes.
Right? So that'll be 1 and 1/5, right?
Okay.
Because 12 over 60 is 1/5, 1 and 1/5. So plug that into the calculator and let me know what you get. Paying you working here, if you look at the graph, we're really looking at the distance between 60 and
You'll get 33.333.
right. What you get? 33 point,
33.333.
we just say 33.33. All right. Okay. Let me ask you a question, right? Where is the gradient steeper? Is the gradient steeper over here or over here? In the first part of the journey or the second part of the journey? Where is the gradient steeper? When I say steeper,
In
I mean it closer to the vertical axis.
in the first part.
The first part,
Yeah, because what support that? If we find the speed for both parts, where was the speed faster? Where was the speed greater? The first journey or the second? The first part or the second part? Where was it faster? Which journey was faster? The first journey or the second?
The first journey.
Right, the first journey. And if it's faster, that means you have a steeper gradient.
first,
Remember that.
Yeah.
Okay, let me do part C now. The average speed of the bus for the whole of the journey, well, all I had to do, right? Um, so to figure out average speed in this case, average speed, that would be equal to the total distance over the total time. Right? So what was the total time? What was here, well, let me do the distance first. What was the total distance? What distance did the bus reach? What distance did the bus cover? Both of them going the same distance.
100.
100, right? So both of them going 100. And what was the total time taken? So it leave at 12 noon and I reach at what time I reach at?
212.
Yeah, I reach at 2:12. So it's 100 all over 2 and 1/5. So plug that into the calculator and let me know what you get. Aliyah, you confused by what I do?
No.
No, so what I do? Tell me what.
Yeah, and the distances.
I add the distance. I didn't add no distance.
Well, no. Like you use the total distance that they give you,
Yeah, because it
which is
went up to
100.
100. Mm-hmm.
Yeah.
And how big
And
time?
the time was the 2 hours and 12 minutes.
Okay, so the person left at noon and arrived at 2:12. So what's the
Yeah.
time there?
2 hours and 12 minutes,
Right, 2 hours and 12 minutes. Right, and if it's 2 hours and 12 minutes, that means it's 2 hours and 12 over 60. So
which is
2 and 1/5. All right, so plug that into the calculator and let me know what you get.
I get 45.45.
Yeah, me too.
45.45.
Mm-hmm.
Yeah.
Where's the units?
Kilometers per hour.
Right, kilometers per hour. Cool. So we do A, B, and C. D now. The time at which the second bus leaves A and the time it arrives at B. That's simple. What time did the second bus leave A? This whole thing here is A, by the way. What time did the second bus leave? I want somebody to tell me.
12:40.
12:40. Aliyah, you agree? Sasha saying 12:40. Do you agree?
Um,
So first of all, where's the second bus?
the second bus,
Yeah, so if this is the first bus,
the second line, the other line, the straight, not
yeah,
the
this one.
straight line, but
Yeah, the
yeah.
straight line, right? Okay, cool. What time did it leave? We know that every small block is six, so let me count. One, two, three, four, five, six, seven. So if it's seven small blocks, how much minutes that will be?
It'll be 12:50 something then because
Nah, 42. Watch.
oh
6, 12, 18,
my bad.
18, 24, 30, 36, 42. Right? So the time is already 12:42. So the time the second bus leave, it was 12:42 p.m. And what time did it arrive at B? I was
Um,
at
hold on. Aliyah just messaged me and she says she laptop dead.
Sharks. Sorry, you can finish up then. What time did it leave? I mean, what time did it reach B?
Um, 2 o'clock.
Yeah, 2 p.m. Right? 2 p.m. So this is when it left A, and this is when it arrived at B. Last question. Actually, no, not the last question. The average. So they want the average speed of the second bus. So the second bus, we need to figure out, well, do we know the distance the second bus traveled? What was the distance the second bus
Um,
traveled? All of them travel the same distance. Huh?
100 kilometers.
Yeah, 100 kilometers. So speed that will be equal to 100 kilometers. And if it left at 12:42 and it arrived at 2 p.m., how long it take?
Um, an hour and 18 minutes.
Yeah, an hour and 18 minutes. So that'll be 1 and 18 over 60. 1 and 18 over 60. 18 over 60 is 3 over 10, right? 18 over 60. Yeah. So what is 100 over 3/10? 1 and 3/10. Let me see how you're going to do this on a Casio. I mean, a sharp.
Hold on. 100. 76.923.
How much?
It'll be 70. It'll be 76.92.
Yeah, 76.92. And that'll be kilometers per hour. All right. And the last question. The time and distance from A when the second bus passes the first bus. Right? So the time and distance from A when the second bus passes the first bus. That'll be over here. That's what they're talking about. So basically, at what point do both of the buses meet each other? At what distance? And you're seeing them interacting with each other over here. See that?
Yeah.
So that's this point over here.
That, yeah. That will be like
So you gotta read that off. That'll be like over here.
6 well, 6. That'll be like 9 minutes before
Wait,
9. Yeah, that'll be 9 minutes before 2.
wait, let me be careful. And the distance go be what the distance go be?
Um,
So remember, I'll check this out. If one big block is 20 and each and one big block has 5, then 5 into 20 is 4. So every small one is 4. So this
that'll
go
be 84.
be
88.
so that's 88 there. And this would be um if this is 2, then this would be that'll be 154 and 154 148 between 148 and 154. That'll be 151. So that's 1:51 p.m. That one was a little hard. Let me show you how to do that. So is in between. I mean, I have multiple ways you can do it. You can account like this 6, 12, 18, 26, no, 18, 24,
18.
30, 36, 36, um, 36, 42, 42,
42.
48, 48 plus 3, because it's half of 6, 48
Yeah, half of
is
6.
51, right? So that's how it goes, 1:51 p.m. So part F, it was a distance was 88, right? So the distance was 88 kilometers, and the time was 1:51 p.m. That's it. So there was only one question only I had to do again, right? And that'll be it for this topic for sure.
Mm-hmm.
Yeah. Maybe I will see you tomorrow, if not Saturday. But yeah, you take care. Have a good
No
night.
problem. Bye bye.
Bye bye.
Tell them I say hi home.
I will tell everybody I say hi home.
Yes.
Well, yeah,
Of course.
later.